All right, let's talk about one of the biggest, most fundamental rules in the entire universe. Seriously, this is a law that governs absolutely everything, from your morning coffee to the ultimate fate of the cosmos itself. So let's just dive right in.
It all kind of starts with a simple question, one you've probably never really stopped to think about. Why can't you unscramble an egg? I mean, you can crack it, you can whisk it, you can cook it, but there is no way, no how to reverse that process. Why is that?
Well, it's because we see this pattern literally everywhere we look. Things tend to, well, fall apart. They mix, they cool down, they spread out. It's just a basic observation about how the world works. And here's the crucial part. They don't just spontaneously fall back together again. The egg stays scrambled. The milk doesn't separate itself from your coffee. A broken glass doesn't magically reassemble on the floor. It feels like everything is headed in one direction. So that really is the central mystery for us today. Why does the universe seem to be a one-way street? What is the fundamental rule that's stopping things from just going in reverse? Turns out, the answer is one of the most powerful and, honestly, profound laws in all of nature. And that rule is the second law of thermodynamics. Now I know, that sounds super intimidating, but stick with me. It's the ultimate reason why things have a natural direction, and why that direction is totally irreversible. At its most basic, it's actually something you already know. You just might not know you know it, right? If you put an ice cube in a hot cup of coffee, the coffee gets colder and the ice melts. The heat flows from the hot thing to the cold thing. It never, ever goes the other way on its own. And what's so fascinating is that this exact same truth was figured out in two different ways. You had the physicist Clausius, who focused on that direction of heat flow. You can't get heat to move from cold to hot unless you force it, like a refrigerator does. But then you had Kelvin and Planck, who looked at it from the angle of engines. They said you can never, ever build a 100% efficient machine. Some energy is always going to be lost as waste heat. It's really just two sides of the same unbreakable coin. Okay, so we've got heat flowing in one direction and engines that are never perfectly efficient. But what's the single idea that connects all of this? What's the thing that's actually changing here, driving this whole one-way process? Well, let's introduce the main character in our story today, entropy. Now, you've probably heard this word get tossed around, maybe described as disorder or chaos. But honestly, a much, much better way to think about it is as a measure of how energy spreads out. Okay, so here's the key idea. Entropy isn't just about a messy room. It's a real physical thing we can measure. It's all about how energy is distributed. So when energy is all concentrated and organized in one place, we say entropy is low. But when that same energy spreads out, disperses, and gets distributed, entropy is high. And this process right here shows you exactly how it works. You start with something like fuel, right? All that chemical energy is packed in there, nice and concentrated. That's a low entropy state. Then an event happens. You burn it. And what's the result? All that concentrated energy spreads out into the surroundings as heat and light. The energy is all still there, but it's way less useful now. Entropy is increased. And you guessed it, this process only goes one way. And that brings us to the mathematical heart of the second law. This little formula right here is one of the most powerful statements in all of physics. It basically says that for any isolated system, that just means a system that's left on its own with no energy coming in or out, the total amount of entropy can never go down. Now, it might stay the same in some perfect theoretical world, but in every single process that actually happens in the real world, it always, always increases. Okay, so this is a really powerful rule. But what does it actually do in the real world? Well, it turns out its consequences are everywhere, shaping our technology, our biology, even our everyday lives. So let's go back to that engine problem. Think about the gas in your car. You start with 100% of that fuel's energy, but because entropy has to increase, you can't turn all of it into useful work that moves the car. A massive chunk, we're talking around 70% in a typical engine, is just unavoidably lost as waste heat. It just warms up the air around you. And that's not a design flaw we can fix, it's a fundamental limit baked into the laws of the universe. And that right there is why perpetual motion machines are impossible. So the next time you hear someone say they've invented a machine that runs forever without any fuel, you'll know exactly why that can't happen. The second law of thermodynamics always stands in the way, demanding its little tax in the form of waste heat and rising entropy. And this entropy tax, it's paid everywhere. It's the reason ice melts in your drink. its neat, ordered structure breaking down. It's why your cup of tea always cools down, its heat spreading into the room. It even happens in the food chain, where energy is lost at every single step, from the sun to plants to animals. It is the universe's most consistent rule, for sure. So we've seen how this law governs heat and engines and all these everyday things. But there is one final implication that is so big, so profound, that it literally defines our experience of reality. So what is it? The ultimate implication of all this is the arrow of time itself. Why does time seem to flow in only one direction? From the past through the present and into the future? It's because the constant, unstoppable, irreversible increase of entropy in the universe is the only thing in physics that seems to have a built-in direction. Think about it. We remember the past because the past was a lower entropy state. We experience the present and we don't know the future. That forward march of entropy is what our brains perceive as the forward flow of time. So let's just end on this thought. The second law isn't just some abstract physics equation. It's really the story of the universe. It tells us that energy is always spreading out, that things tend towards their most likely state, and that the cosmic clock, driven by the endless rise of entropy, only ever ticks forward. It's the law that explains why eggs don't unscramble, and why we can never ever go back.